So you can see the 0 slide. Today just I will give some brief about this course. So then we will go for the further discussion on the course. Okay. So first thing is I would like to tell everyone that for every class you should be ready to join minimum 5 minutes early, so that I cannot wait for you, since it is a first class, so we are allowing people to join. We are waiting. So if you wait like that, out of 15 minutes we are putting 15 to 20 minutes in that, so teaching is very difficult. So everyone make sure that you join 5 minutes early, be ready to join, and I can start my class at right time. Another thing what I would like to tell is, you maintain one notebook, a separate notebook for this. So whenever I am explaining these topics, so sometimes I will be going through the writing on a whiteboard. So those things you need to note. And sometimes I will instruct you to note some important definitions or some important headlines. So you need to be ready with your notebook. Okay. So next time you should come with a notebook, and always you use the same notebook for every class. It's clear? Yes, sir. So 1 second. Some people are writing here. All of you mute yourself. Only when you have the questions to ask, just you unmute and talk, so it will disturb for others. So better everyone mute yourself. I hope everyone are able to see my screen.
No, sir.
Okay, so I'll go ahead now. So the course name is Analog Communication, and this slide I am going to share with you all people. So this is the 0 slide. So it contains complete detail of this particular course. So let me go through this in brief. So this course is offered for BTech, only for ECE students, and you can see the details of head of the department and dean, and it belongs to the Faculty of Engineering and Technology. And the objective of this course are mentioned here. Just you go through that. I will share this slide to you. I don't want to go one by one. So the aim and summary of this course is to understand some fundamental concepts of random process, Fourier analysis of the signals, and basically analog communication systems. And here we are going to discuss about different modulation techniques used for analog communication system. So basically in communication there will be of two types. One is called analog communication, one more is digital communication. So in this course only we are very particular about analog communication. We are not at all touching with the digital communication, since that particular course is offered to you in the next semester. Okay. So in this semester, for this particular course only we are dealing with analog communication, different methods of modulations, and we are also going with some part of the random process, and we are learning how to analyze the signals using Fourier transforms. Okay, so this is what the main aim of this particular course. I hope for everyone this course is very useful, since your branch name itself is electronics and communication, and this is the first subject you are studying as a communication subject till now. So you may be having some other communication subject, but this is the one basic subject which you need to study and understand very clearly. So there are some ILOs for this particular course. So here we are explaining you the random processes and its relevance in channel distortion and noise signal, and also we are describing you the Fourier representation and analysis of some signals which are very useful for analog communication systems. And we are also simplifying or solving some numerical problems related with analog communication system design, and we are going with some set of derivations and some analysis of different modulation schemes so that we can check their performance in terms of bandwidth, modulation index, efficiency, transmission power. And also we are looking at design and analyzing those designed analog communication systems. And along with that, we are simplifying some complex problems related with analog communication, and we are comparing those results with that of solutions obtained in a software tools. So basically these are all some ILOs we are expecting from all of you. Okay, so once you complete this course, you people will be able to perform these ILOs. So this is the complete course content, what you are going to call it as a syllabus. So this is the syllabus for this particular course. It's called a course content. So it has some chapters like random process, Fourier representation and analysis of signals, amplitude modulation and demodulation, angle modulation and demodulation, mute it, and noise in continuous wave systems. So these are only some chapters we are going through in this semester. We'll go one by one in detail, and these are some common parameters. That is a method of assessment. As you know, there is a continuous evaluation which carries a 50% marks, and it contains a tests and assignments. So this time I hope some other course might have explained you will be having a 2 term tests and 2 assignments, and one more will be a quiz or a test, 5th one. Totally the 5 parameters are there in component 1. 2 tests, each of 25 marks, 2 assignments, each of 25 marks, and either will be a 1 test or a quiz, any one, that is a 5th component. Out of 5, the best 4 will be taken, and it will be considered for a 50% weightage of your this course complete marks. So that I will put it in this PPT and I will share with you. And obviously, you know, second component is a semester end examination, which carries the remaining 50% weightage, and it will be a theory exam of duration 3 hours, and the maximum marks of the question paper will be 100 marks. So already you know this thing. And there are some references which you need to follow to learn this particular course. The first one is class notes, which I am sharing with you. And there are 2 textbooks you can see in essential reading, textbook number 2 and textbook number 3. Communication systems, John Ville publication, author is Simon Hawking. It's a 1996 version. And one more textbook is an introduction to analog and the digital communication. Again, it's published by John Ville, and author is the same, Simon Hawking, and it's published in 2003. So I think these 2 books are the one which covers the complete topic of this particular course. Okay, and the recommended readings are some textbooks are there. They are very good. One is BP Lathi. Its name is Modern Digital and Analog Communication System. One more is Harold P. Sammy S. Textbook name is Communication System. And one more is Staub and Schilling. Textbook name is Principles of Communication System. And if you want, you can go through some IEEE magazines or IEEE Spectrum magazine. And there are some websites which gives much content about this particular course is rfcafe.com, and some electronic resources you can find it online from the some top universities of the world like MIT. Its link is given here. So the Springer publication, it's published article will be there, and so many study materials you may get it through it. So these are all the references which you need to refer for your course. So this is a very basic introduction about this course, and there are different topics. I will share anyhow to you people about these topic details, and it's a 4-credit course. All of you remember it? It's a 4-credit course. Yes. Okay. So, so I will just 1 second. I will share. Doubts or any questions related with this course?
What is the use of this course in practical life?
Can you repeat it? Can you just tell me a bit loudly? I'm not able to hear.
Sir, what is the use of this course in practical life?
Yes. Very good question. So today I'm taking a session to you online, since there is no offline classes running throughout the India and most of the countries because of this corona pandemic. So this is the one great application of this. If there is no communication, then I may not be able to connect with people, and I am not able to give this presentation. This is a one small application. So in our morning to evening day life, every time you will be using most of the things which have the communication as the one of the important technology. Starting with your television, radio, internet, telephone, mobile. Yes, it has n number of applications. You cannot imagine whatever the communication is happening. It may be a voice communication or a video communication, audio communication, text communication, even it may be a signal communication. Everything will be based on this particular principle. Is the question clarified? Did you get the answer for your question? Yes?
Yes, sir.
Anybody else? Anybody else wants to know something about this course? Yes? Can I go ahead now?
Sir, can you summarize the course again? I was not in the class.
See, already it's 30 minutes over and you are late. I cannot go everything once again because already we delayed by 15 days. So you should be in time. So I didn't given any topic explanation, just I have given the introduction about the course. So I don't want to put much time in that again because already so many students have attended and they don't want to repeat the same thing to them. So better be next time in time. Okay. And I think I'm recording this. If possible, I will share this video to you people. Okay. Yes.
Yes, sir.
Okay, sir.
Okay. So everyone have studied a course called Signals and System. Is it?
Yes.
Studied or not?
Yes, sir.
No, sir.
Yes, sir.
And most of you
Yes,
have
sir.
passed that course.
Yes, sir.
Passed. Passed or failed?
Pass, sir.
I think almost all have passed that course. Okay. Then there you might have studied different types of signals. Is it?
Yes, sir.
Okay. So can you tell me any examples of the signals?
Step signal, ramp signal,
Okay. Then
exponential signal,
Then
rectangular signal,
okay, good.
unit
You said
impulse.
something. What about others? Anybody else?
Periodic.
Real and complex signals.
Same, same.
Yes. Then
Energy signal,
Even and odd signals.
okay.
deterministic signals,
Deterministic signal, good. And random signal, okay.
Continuous signal.
Okay, good. So that means you know you didn't simply pass the course. I think this course was passed in lockdown, no? Everyone?
No, sir.
No, sir.
No,
Third sem
sir.
or fourth sem?
Third.
Third
Three
sem.
semester.
This is third sem. Okay, then you are
Third sem.
okay. Good. So now you might have studied a topic called Fourier transform. Did you study it?
Yes, sir.
Yes.
Yes, sir.
Okay. So the first lecture, what I am going to teach is a Fourier transform. So you can see the lecture number 1, the Fourier transform. Okay.
Gendo.
Okay. So this Fourier transform, can anyone tell me what is the meaning of Fourier transform?
Time domain to frequency domain.
Fourier transform means what?
domain signal.
So I am just going with this pen. So since it's the first class, so it takes 2 to 3 days to adjust this. So can anyone tell me what is the Fourier transform?
Time domain to frequency domain.
Okay, good. Anybody else? What is the meaning of Fourier transform? All of you are able to hear me? Everybody is waiting in the lobby. But I can add them. Okay. So let us see. What is this? You are visualizing a signal. Are you able to see the signal? Any signal are you able to see in real time? Can you see in real time?
No, sir.
No.
ECG, sir.
Yes, you are not seeing the signal. You are not able to see the signal. Just I am visualizing a signal. I don't know where the sine wave comes in real time. I cannot see from my naked eyes. Just it is a visualization. That means we are visualizing a signal, and also we are representing a signal in the graph. In a two-dimensional graph, we are representing a signal. Yes? Is it correct? Am I correct? What I am telling? Yes or no? So what we are doing
Yes,
is
sir.
you are visualizing a signal in a two-dimensional graph like this, and on x-axis we are taking a parameter called time. On y-axis we are taking a parameter called amplitude. Correct? So that is what this signal is. You can see here there is a time axis here, and there is axis called amplitude. So this is what the most common representation of a signal. Am I writing a sine wave, or a cos wave, or a triangular wave, or a exponential wave, or a rectangular wave, impulse, unit function, ramp, so many waves, whatever you are writing in a regular practice as an electronic engineer, x-axis will be time. Do you agree this? Do you agree this? What is our common practice? Writing a signal in a time domain. That means x-axis I will take a time, and y-axis I will take its amplitude. So that representation is called as time domain representation. What is the representation called as? Time domain representation. A same signal I can write in frequency domain also. So writing a signal in terms of frequency domain, that means instead of taking this x-axis as a time, if I take it as frequency, then this is called as frequency domain representation. Is the point clear? That means I can represent a signal either in time domain or I can represent signal in either in frequency domain. So if I represent a signal in time domain, it looks like this. So this is time domain. If I represent signal in frequency domain, the signal looks like this. This is called a frequency domain. Is the point clear? So let me just summarize this in clear. So a signal, any signal may be a sine wave or a cos wave or triangular wave or an impulse or ramp or pulse. I can represent a signal either in time domain or in frequency domain. The most common way of writing a signal is in time domain. So there is a parameter or there is a transformers. There are some transformers available which converts a signal from time domain to a frequency domain. That is called a Fourier transform. What is Fourier transform? So it is the transform which converts a signal from time domain into a frequency domain. Now my question is, why I need to convert a signal from time domain to frequency domain? Can anybody tell me what is the use I will get if I convert a signal from time domain to frequency domain? Anybody can?
For image
Yes.
for image processing, sir.
Can I make? I'm not able to hear you clearly. Just complete the word. You're not talking completely.
Decomposes
You
the
can
signal.
apply Laplace transform.
Sorry.
You can apply Laplace transform.
Anybody else? Why I need to write a signal in the frequency domain? What is the use? Yes.
Like ECG.
Sorry. Yes. Can anybody answer this question? ಜರ ಎಲ್ಲ ಹುಡುಗರು ಪ್ರಶ್ನೆ ಇನ್ನು ಇವಾಗ ಹೆಂಗೆ ಗೊತ್ತಾಗುತ್ತೆ. Are you able to see my screen?
Yes, sir.
Yes, sir.
No, sir.
Okay. Okay. So what is Fourier transform? What is Fourier transform? So ಏನೋ ಇದರ ಇಲ್ಲ ನಮ್ಗೆ ವಯಸ್ಸು ಹೋಗ್ತದೆ ನಂದು ಏನ್ ಬಂದ ಈಗ 11 ಜನ ಗುಡ್. Yes, can anyone tell me what is Fourier transform? Unmute and talk. I'm not able to hear anything.
Converts the time domain signal into frequency domain.
Okay, it converts a time domain into
Frequency domain.
Frequency domain.
No
okay, you might
screen,
have
sir.
already studied about Fourier series, correct? You can see the difference between Fourier series and Fourier transform. Just mute yourself, some disturbance are there.
Sir, your screen is not visible.
Yeah,
The screen is not visible, sir.
screen is not visible.
It's visible, sir.
Maybe your internet problem, just you check.
Screen
So,
not visible, sir.
Fourier series and Fourier transform, how do you compare? Or what is the basic difference between Fourier series and Fourier transform? You can see in this slide, a small comparison is made between Fourier series and Fourier transform. The Fourier series is for a continuous time signal and a periodic signal. If a signal is of continuous time and aperiodic, then it is a continuous Fourier transform. If the signal is a discrete time and periodic, then that Fourier is called as discrete Fourier transform. If the signal is of time and aperiodic, then you can apply discrete Fourier transform. That means the Fourier transform is used particularly a discrete Fourier transform for aperiodic signal, and the signal will be of type discrete time. You can see here the Fourier series is for continuous time periodic signal, and Fourier transform is for continuous aperiodic signal, and the spectra is called continuous spectra. And for Fourier series, whatever spectra is, that spectra will be of type discrete. Just you highlight these things, just you note down these 2 points. ಮ್ಯೂಟ್ ಮಾಡೋಣ ಬಿಡಿ, ಹೋಗಕ್ಕಾಗಲ್ಲ ವಾಪಸ್ಸು. ಟೈಮ್ ಹತ್ತು ಏನಿಲ್ಲ ಅಲ್ಲಿ ಆನ್ಸರ್ ಇಲ್ಲ, ಏನಿಲ್ಲ. ಏನ್ ಮಾಡಿದ್ 120 ಜನ ಇದ್ದಾರೆ. ಟೊಯ್ ಟೊಯ್ ಅಂತ ಏನೋ ಅಂತಾನೆ ಇಲ್ಲ. ಶೇರ್ ಆಗ್ತಲ್ಲ ಸ್ಕ್ರೀನ್. Okay, so this is the definition of Fourier transform. If you want, you can note down this. Definition of Fourier transform, and this is the formula to calculate a Fourier transform of any signal. If a signal is g of t, its Fourier transform can be calculated like this: integration of minus infinity to plus infinity g of t into e to the power minus j 2 pi f t with respect to t. And the representation of signal g of t in a frequency domain, you can symbolically represent as capital G of f. This is called the Fourier transform of g of t. What is g of f here? G of f is the Fourier transform of g of t. If you want to calculate a inverse Fourier transform, that means if you want to convert a g of f back to g of t, so there is a formula to calculate an inverse Fourier transform, that is integration minus infinity to plus infinity g of f into e to the power of plus j 2 pi f t with respect to f. So here g of t is a signal in time domain. This is a time domain signal, and G of f is a signal in frequency domain. So converting a G of t to G of f, this is a Fourier transform. Converting back G of f to G of t, it is called IFT, inverse Fourier transform. And there is a property called time frequency duality that I will explain separately. So there, if G of t is Fourier transform with G of f, then capital G of t, whose Fourier transform will be small g of minus f. So we say this is called a nearly symmetry because the sign in the exponentials are different between Fourier transform and inverse Fourier transform. So this is a basic definition of Fourier transform. If you want to calculate Fourier transform of any Fourier transform of any signal, then you can use this formula. Inverse Fourier transform, you can use this form. I hope everyone have studied this in your previous semester. Can I skip this part, Fourier transform, and go ahead with the next topics?
Okay, sir.
Yes,
Yeah?
sir.
Are you able to calculate Fourier transform of some standard signals?
Yes, sir.
So then we will solve some problems and in the next class. Okay? But next class everyone should be in time. So if you are entering late, your attendance will not be calculated. Okay? So this is the software based attendance who are logging